Assalamualaikum and hi everybody. Today we are going to learn about related rates on MAT183 Calculus 1 for Assessment 3 by Arifah, Auni, Isa and Alia. Before we going deep into this topic, let's get to know our member. First member is Nur Nisa Akila Muhammad Rahimi. The second member, Nur Auni binti Ahmad. The third member, Nur Alia Maisara binti Muhammad Razali. And the last one is Arifah Umara binti Muhammad Swadi. Next, let's get to introduction of related rates. What is related rates? In related rates application, we try to find the rate at which one quantity is changing by relaxing it to other quantities with known rate of change. The rate of change is usually expressed with respect to time. Now that we have finally understand what is related rates, let's move on to the procedure. How are we going to answer a related rates question when it's given? First step is identify the rate of change that are known and the rate of change that is to be found. The second step is construct a formula or a quick equation that relates the variable in step 1. You can try to draw an appropriate level figure so that it will be easier for you to understand the question and to solve the question. Step 3 is differentiate both sides of the equation by using implicit differentiation. After that, then you can substitute all the known terms or value given. With that, you can solve the unknown and get the answer.
So let's take a look at the question. Wheat is poured into a conical pile at the rate of 20 cm3 per minute, whose bottom radius is always half the height. How fast will the area of the base be increasing when the pile is 16 cm high? So let's move to the solution. First step is we need to identify the rate of change that are known and the rate of change that is to be found. As we look at the question here, I have highlighted the information that we use in this solution. So the dV per dt is 20 cm3 per minute, and what are we going to find here is the area of the base, which is the dA per dt when the pile is 16 cm high.
Next, we need to construct a formula or equation that relates the variable in the first step using area equation, which is A equals to pi r squared. And then, you need to differentiate the area equation to area respect to time. Then, you need to substitute the value given that we already take out from the question into the dA per dt equation, which is our value r is half the height. Our height is 16, so we need to divide it with 2. And then we got 6 for our radius. So our radius is 6. So you guys understand?
Yes!
So now we need to find the dr per dt value. So we use the formula of volume, which is 1 over 3 pi r square hash. In this formula, we saw that there are two variables in it, which is r and hash. So we modify the hash in terms of r, because here we want to find the dr per dt value. After we modify, we substitute. Now we need to find the dr per dt value. In finding the value, we need to use the volume formula, which is 1 over 3 pi r square hash. In this formula, we saw that there are two variables in it, which is r and hash. So we need to modify the hash in terms of R because here we want to find the dr per dt value. So we substitute all the terms. So we substitute all the value, and the latest formula is V equals to 2/3 by R cubed. After that, we differentiate the formula respect to times. Again, substitute all the value given, and then it's gonna be 20 equal to 128.5 dr per dt. Now we need to change the subject into dr per dt, and we got dr per dt equals to 20 over 102. We need to change the subject, which is dr per dt. So it is dr per dt equals, and then now we make the dr per dt as a subject. Calculate it, and the answer is 5/32 pi.
Furthermore, we substitute value dr per dt into dA per dt equation. So we got all the value to find the area of the base. Finally, we can solve the equation by using calculator scientific. And the answer is 5/2 or 2.5 centimeters squared per minute.
So now we are ready. Now we are ready to finish the conclusion breakdown. So now we are ready to finish the question. To conclude this, related rates are important because often one variable rates over time will impact others variables rate over time. If one rate, now we can determine how the other variable is changing using calculus. The benefit of learning related rates are help engineers to work more professionally and keep the flow of work efficiently. It's help. The second one is help you to get a better grip to other subtopic of differentiation. That's all on us. Thank you.